In late December of 2022, we had a cold snap in the United States. I thought this spigot was well protected. I had foam insulation over it, plus it had a heater coil on the other side. Yet, in early January when I went to wash my car, because the temperature is up in the 60s, no water came out of here. Water did pour out of the back. So I did notice that if I shut off the valve, the water would stop flowing. So that let me know that the break was before the stem that closes off inside this pipe. So I knew this was shot, but all I needed to do then was replace some pipe. So I have a pipe that comes from the spigot. It looks like it's maybe threaded on here, so I might be able to twist that off. If so, I would like to go with some PEX, only so I can use that as a thermo brake. If this is sweated on, then I have a problem because I'm gonna have to cut some pipe. So the first thing I'm gonna need to do is just clean up this area, because obviously they've done repairs here before in the past. I am lucky because there's a shut-off valve here, so I can disconnect all this and not worry about water leakage. Here is the heating coil. I'm going to remove that. I'm going to clean this area up. I think overall what I want to do with this project is not only replace the spigot, but maybe cut this out and insulate this cavity so that there's some thermal insulation, so we can hopefully prevent this from happening again in the future. Before running off to the hardware store, the first thing I'm going to do is remove that fastener and that nail, and then we'll see if we can spin this off the thread, or if it's sweated on, then we'll have to do some cutting. But we have to remove this anyway, so might as well get this out of the way now. Using a flat blade screwdriver, got rid of the fastener and pulled out the nail. And it doesn't look like the fastener was holding on too much, and the nail was doing even less. Looking at the back, here's the piece. It looks like it might be threaded in place. The thing that we have to note is that there is no support for this pipe. In other words, if I start applying torque on the spigot, there's nothing to keep this from taking some of that force, because it's not fastened to any structure. So I'm going to have to get an assistant to put some pressure here and to make sure that when I do twisting over there, I'm not twisting and possibly damaging any of the connections along this pipe. Using this wrench, I applied force this way, but notice that as this turned, there was no turning on the thread. So looking back inside the pipe, we can see there in the back that the little break in the pipe is just enlarging. So basically, this copper pipe, the spigot attached to it, is just finishing ripping that metal apart. So I'm just going to finish twisting that off because we got to get rid of that pipe anyway. So, but it's important that we hold this still and we don't do any damage to these connections below. So now the problem we've run into is that the stem still goes into the pipe, but it won't release. It's bound up in there. And I guess it's a moot point because we have to cut that pipe anyway. So looking back here, there's the broken pipe. And I thought maybe it would spin off of here, but it won't. This is sweated onto this elbow, which is sweated onto this piece of pipe. So my options are to cut below this elbow and then replace everything going up above. So I'm going to look for a cutter so I can make a clean cut on this copper pipe. Not locating my copper pipe cutter, I have a multi-tool, and what I'm going to do is I'm just going to cut here at the top of the elbow That's going to do just one thing. That's going to enable me to get this pipe out. One nice thing the Dremel does is, unlike a saber saw that's going back and forth really fast, it puts minimal vibration on all the structure because it's just the blade oscillating. Plus it also gives you a much cleaner cut. So now hopefully we can get this pipe out. As can happen with these projects, sometimes there are problems. So the knuckle on this is too big to go through that opening, so I need to come back this way. This pipe, of course, is in the way. So I came down here, and there's a nut here. Looks like a compression fitting. So I'm just gonna take that off. There's some residual water there. Make sure that you counteract with a plier on this so that as you're applying pressure to loosen this, you're holding this one still. Otherwise, you'll just loosen the next coupler down. So with this out of the way, I can actually remove this pipe from this fitting, and this is a threaded compression fitting. And now I should be able to get a bite on this piece of pipe and pull it, what's left of it, pull it out. And indeed, working with this crescent wrench, we're able to get the rest of the pipe out. Using a tape measure, I'm able to determine that I have about 11 inches to dead center on this pipe. So now I know how long of a spigot opening I need so I can get by with an 8-inch spigot and then add an extension to bring out the rest. Plus an elbow down into here and that compression fitting. So now all I have to do right now is just, if you push down on this evenly, it should release the copper pipe from the compression fitting. To release the pipe from the push fitting, if you grab an adjustable wrench and then you push down, you make it tight enough so that it's over this ring, and you push down on the ring, then you have somebody pull up, it should come right out. Oh, now it's in. So maybe you'll actually get to see it. Let's see. You push down, and this saves you from having to buy a specialty tool from, like, shark bite to actually remove it. So the trick is just pushing that ring down and it will release whatever pipe's attached to it. Coming back from the big box store, I ended up with a shark bite spigot, and you see there it's just the push-on connection there. It's a quarter turn to close, which I really like. I got an elbow. I got a threaded to compression. I already have one, but I decided, if I'm going to do this, I might as well just use all new parts. That way, if somebody messed this up and damaged the O-rings in here when they first installed it, that won't be an issue for me. Of course, you're going to need something to cut some pecs with, because we're using pecs here. Something to measure with. Since we're going to attach this thing and it's threaded, we're going to need some pliers, so have a few of those around. And then I bought some landscape adhesive, so I can pour some of that inside the opening so that when we put the spigot in, it has something to bite into. And of course, some pecs. I happen to have some leftover pecs, 1/2 inch from a project. So all I have to do now is tear this open, because I want to redo this so that we can get some insulation. So I'm probably going to make a cut across here and clear this out. Plus it'll give me some room to work with, and I can better install some foam insulation. Once again, I used the multi-tool. I drew a straight line across, a level line, and then did a cut that way, came down, split the board, came over on the other side of this circular opening, opening and dropped another cut. So now I can start pulling this apart. Discovered some nails, so I'll use that to get them out, get those out of the way. Then I'll do the same thing on the other side. Once this is removed, we can actually start doing some real plumbing. With all of the debris cut out, we have a nice clean open. This is actually a little bit below garage level. Probably will put some foam insulation there just to beef that level up. And I'm going to put some foam back here because it's just plywood, and then the veneer brick. So that'll give us some insulation. And this cavity goes way up there, but I only need to seal this portion of it because this is where there's actual water. The rest of it's just electrical, so there's no need to deal with that. I got some project foam. It's a 2x2 board, 1 inch thick, so it'll give me some R value and it'll be easy to work with because you can just cut this with a utility knife. While running a fan to dry out the interior, I stuck in my PEX tubing to make sure that it goes all the way through. And now what I'm going to do is get my PEX cutter and make sure that I have a nice square clean cut so that the spigot can mount into that easily. We will make the connection to the spigot, feed the line through, and then cut at the other end because it's much easier to do. And then plus that gives us the opportunity to pack this with some material that will hold it in place once everything's mounted. I cut 2 sheets of the foam back to back, wedge 2 at the bottom so there's some elevation, so in case there is some water leakage or condensation, it has a place to go other than just rotting out the boards. With the foam insulation taken care of on the inside, we take our shark bite spigot, and it requires almost an inch of the PEX to go into it. So what we're going to do is we're going to measure that so that we know exactly, it's like 15/16 of an inch, so almost an inch. So now if we mark that, we know how far this needs to travel before we know we've made a good connection. And at this point, it doesn't matter if it's upside up or upside down because it's just a piece of pipe and it's not hooked up to anything. So, and don't take out that little sleeve that's inside there. You need that to make this work. So we line it up. We have a clean cut and we push. And we push, and if you look, my blue line is against the spigot, so we know that's a good connection. So my next thing to do is to put some material in here so that when this spigot goes in, the fasteners have something to hold on to, and we fill this cavity up a bit so there's no air leakage and it actually lends some support to this spigot. So since I have an opening, now is a great time to do that. We have some landscape adhesive, which I'm going to squeeze around here. And again, the purpose of that is to provide some place for the fasteners to bite into, and also just to seal up this opening so we don't have air leaking into the interior. Now is the best time to do it because the spigot is not in the way. And this takes a while to set up, so it's not like it's going to hold the fasteners today, but I'll put them in there, so hopefully as this dries out, it'll just hold the fasteners in place. And we're going to get some underneath. Okay. And I'm not trying to make a big mess out here because that's unsightly. Wipe off the tip, pull back so there's no more pressure on this so it doesn't leak out. All right, so now we're going to go on the inside and finish our installation. With the spigot flush against the wall, we pulled back on the line. I found my center line where I want to cut this. So I come in with my PEX cutter. We want to make a nice, clean, perpendicular cut to the tubing. And that looks like a really nice cut there. So once again, I'm going to measure about 1 inch and mark that so that I know how far to push that connector in. And with that connector pushed in that far, I still have, it's not perfect alignment, but I want a little up so that this drains when it's open and there's no water in here. So now we just push in our connector, and you can't see the line any longer. So that connection is made. Now all we have to do is put our threaded fixture here that goes to our push-in connector on top. Then we have a small piece of PEX pipe that I'll cut, and then I'll be able to push that down. So I'm just going to attach this to here. And I put on Teflon tape clockwise. About 3 wraps should do it. And then I'm just gonna make sure this is snug. Okay, so now we measure this distance, but remember it's this distance plus 1 inch in here and 1 inch in here. So you have to take that into account when you do your measurement. And then of course I'm going to check on the other side, make sure that that fixture is aiming down the spigot, so that it's not off to one side or the other, because I can't see from this point. But we'll double check that, and then also we'll make sure that it's snug up against the wall. In this situation, we've determined that it's going to be 4 inches, including the amount that goes into the upper and lower push connector. And we simply mark the tube. We'll make our cut there, and then we'll push it into the connectors. Our 4-inch PEX, I locked it into the top connector first, just by turning it, because the connectors will turn freely. Then once that was secured, then I just pushed down into this connector and it fully seated. We have the construction adhesive in here, so all I'm going to do is I'm just going to drive these into here. And not that they're going to catch onto anything, but when that adhesive dries, these will be embedded in the adhesive. So that mound, which is adhering to the brick, should also adhere to the fasteners. I'm going to need a driver to push that all the way in there. But that's the plan with this. And on the back, I'm going to show you one more thing, because you see how it's being nicely held. Well, you need a little back pressure, at least I do in this case. So let's take a look. So since I needed some back pressure holding that spigot up against the wall, I just took a piece of scrap foam, and that's wedged in there, and it's just providing a little back pressure, holding everything in place. Then if you want, I guess I could just leave it there because it's not going to hurt anything. And it's just another piece of insulation. But we got double insulation here. I put some insulation up above here because this is just an empty cavity, but I wanted to block it off so there's no cold air dropping down. And whatever I have left of the foam, I may just stick in here just to use it up. Then the idea is to put a panel over this. The one issue is that, you know, if a panel comes down, then this pipe is on the outside. I'm trying to make this a conditioned space, meaning this is the space that's heated or being cooled from the inside of the house versus the outside air, because the garage, when closed off, is warmer than the outside or cooler than the outside generally, because there's heat escaping or cooling escaping from the house, and so that affects the air temperature. So generally, a long way of saying that the air temperature in a garage is usually warmer in the winter than it is outside and cooler in the summer than it is outside. So by making this part of the conditioned space, less likelihood that this will freeze up. Plus, I can also wrap insulation on this and maybe put a heat coil on it if I can find one that's appropriate. I don't want to reuse the one they had. It's very old and I'd rather have a new one. Also, I noticed that there's this valve that was originally here, and this valve has this little side cap here. When you remove that cap, that allows you to drain whatever is above. So, I didn't know this. I didn't even know it was here. But now in the wintertime, I would leave that fixture open, the spigot outside open, so it drains. And then I could also open this and drain the line at least down to here. And again, this is the conditioned warmer space. And if I have some insulation or a heating coil on it, then I shouldn't ever have this freeze again. So the moment of truth, we open up the valve, we have water, and hopefully it's coming out. You'll probably see it on the other shot. No leaks here, no leaks here, no leaks here. There's some mild dripping here, so I need to tighten this little drain. And I think there might be something here. So that'll be another project. I may have to repack this. Maybe this washer's worn out over the years, or maybe it just needs a little bit of tightening. Sometimes if you turn it a little bit with a wrench here, it'll stop that. So, but our part of the plumbing is fine. I can actually wash my car now. Okay, so indeed, I just tightened that a little bit and this nut here, and I don't see any more leaks. Do realize that this is prone to freezing because the stem is right here. So any water here that freezes could split this open, but we have 3 lines of defense. The insulation cover that goes over the spigot, the 2 thermal brakes, which slow down the coldness from coming into this area, and a relief port on the valve that allows us to drain all the water in this line right to the valve. So the only thing we really have to protect in cold is from the valve down to the floor. If you found this really interesting or useful, even if you didn't, give us a thumbs up, leave us a comment, join the subscription team. And as always, thank you ever so much for watching. And yes, I did get to wash the car.